Why is reading engineering drawings important? This is a question often asked by many. Well, the answer lies in the fact that these drawings are a universal language in the field of engineering and manufacturing. They serve as a crucial bridge between the design and the actual product. Step 1 is understanding the drawing format. The title block, located usually at the bottom right corner, is like the cover of a book. It holds essential information such as the drawing title, sheet number, and scale. Adjacent to it, you might find a revision block, which chronicles any changes or revisions made to the drawing. The scale, a critical component, indicates the proportion between the drawing and the actual object. The second step is to identify the type of drawing. Orthographic projections, the most common type, showcase 3 views: front, top, and side. Isometric projections, on the other hand, provide a 3-dimensional perspective. Then there are sectional views, which reveal the hidden internals of an object. Step 3 involves understanding lines and symbols. Continuous thick lines, or visible lines, represent the edges of an object that can be seen from the current view. Hidden lines, represented by dashed lines, depict edges not visible in the current view. Center lines indicate the center of a cylindrical feature, and dimension lines show the size of features. Next, it's time to grasp the symbolism. Symbols represent specific features, materials, or processes. Surface finish symbols indicate the required surface finish on a specific part of the object, while welding symbols provide information about the type and location of welds. Annotations form the 5th step. Notes and labels provide additional information, specifications, or instructions, while material specifications indicate the type of material required for a particular part. Moving on to interpreting dimensions. Dimension lines show the extent of a dimension. Arrows indicate the direction and extent of the dimension, and numerical values provide specific measurements. Tolerances form the 7th step. Tolerance notations indicate the acceptable variation from the specified dimensions, while geometric tolerances specify allowable variations in form, profile, orientation, and location. Step 8 involves understanding assembly drawings. Exploded views illustrate how components fit together, and the bill of materials lists all parts and materials needed for assembly. Cross-referencing forms the 9th step. Large assemblies may have sub-assemblies with separate drawings, so it's important to refer to other drawings as well. Finally, just like any other skill, practice makes perfect. Start with simple drawings and gradually move to more complex ones. Use reference materials like textbooks and online resources for additional guidance. Remember, reading a drawing is a sequence. Follow the flow from title block to views and annotations. If something is unclear, don't shy away from asking for clarification. Reading engineering drawings is a skill that requires practice and familiarity with industry standards. So don't hesitate to seek guidance and continually refine your skills through practical application. After all, these drawings are your roadmap to bringing ideas to life.